Hey everyone, welcome back to my channel EduVibe. In today's lesson, we're starting with the next unit of the last unit of the grade 11 chemistry, which is a quantitative relationships in the chemical change. This is a short unit and we're covering like in a few days. And in today's slide, we're doing some simple topic called the chemical reaction equations. This will be already done in grade 10, but now we are just doing overview of this because this chapter starts from here and next topic is also related to that, which is a new for grade 11 chem. So let's start with this and we're doing some different types of chemical reactions too, which we already done. So states of matter. So what are the states of matter? You know that when we write in any reaction, in the last unit when we write any reaction, we write it as a something in brackets like solid, liquid, gas, or something with like aqueous solution. These are the states of matter. We have to mention these when we doing the chemical reactions, when we do any equation, when we write in chemistry. So the states of matter for elements are communicated in element box on the periodic table. All ionic compounds in their pure form are solid at the room temperature and pressure. So all the ionic compounds, if they are in the pure state, so they are the solid. So if they have like a room temperature and they have a same pressure. For ionic compounds in aqueous solution, they are referred to as a solubility table. So when we have a solubility table, any ionic compound is which lie on that and which is soluble, you can write it as a aqueous. So if the compound is highly soluble in water, the state of matter is aqueous. If there is a slightly soluble in water from your solubility table, so it's a solid. So state of matter, molecular compounds is more difficult to predict. So molecular compounds are more difficult to predict. You're expected to know that the states of matter for the common molecular compounds. So there's nothing way to doing the like difficult to understand it what is the state of matter for the molecular compounds. So you have to know for the common molecular compounds states of matter. Generally the smaller molecule tended to have a gases and the larger molecule tended to have a liquids or solids. So when we're doing the some of the reactions, you will come to know that what are those molecular compounds which we use regularly, like in the kind of the in every topic. So we start with the types of the chemical reactions. So first one is the simple formation. So what is simple formation? So when two animals combine to form a compound, we have A plus B, they form the compound which is AB. So the two elements combine to form a new compound is called the simple formation. For example, we have there the magnesium reaction with the sulfur. So magnesium you know is Mg, which is in solid, so this is the element, plus sulfur, and you know that sulfur has S8. So how do you know that things which has like some things in the periodic table, they have a 2 like Br2, Cl2, they have this type of thing, and like S8 which is sulfur, and phosphate which is as a P4. These are the two things we have to know, that phosphate has to write with the help of like P4, and sulfur is S8, and sulfur S8 also is solid. This P4 is also in solid. But there are some elements in a periodic table which are like nature has the twos. Like Br, I, N, Cl, HOF. So it's a bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. These are all come in the nature as twos. So you have to know this thing, know this small word to know that these are have the two things. They are in nature as two. So we have a magnesium with sulfur will make, so this has the 2 plus, this also have 2 negative, so we'll make MgS. So you have to know that, and this is also in solid. So to know that how to make things. So magnesium is 2 plus and the sulfur is 2 negative, they cut out and that the MgS. So now you have to balance this. So here we have sulfur 8, so we have to write 8 over there, so 8 also comes over there. So now this is balanced. That so these are all the like grade 10 stuff. You all know that how can you do these things. Next we have to write the reaction of the iron with oxygen. So iron is Fe, which is again solid, and oxygen is O2 gas. So this reacted. So iron we take 3 plus and the oxygen we have 2 negative. So the interchange, so we get Fe2O3 which is in solid. Now we have to balance this. So here we have a 2. So if we write 2 over there, so we write 4 over there. The oxygen is 6. So oxygen is 6 over there like this. You know how to balance this? Easy method. You can do whatever you want, whatever you know, so you can do with this. Let's do with the next thing, which is a simple decomposition. First, we do the formation, now we do the decomposition, which is a simple thing. So in this, the compound breaks down into its individual elements. We have AB now, we have a compound, so it breaks down into A plus B, the reverse of the simple formation. So the first one we have the decomposition of the water. So water is H2O, which is liquid. So decomposition is by H2, they made by H2, which is liquid, or yeah, liquid, plus O2 gas. So they made with those. So we have to balance this strictly. So this is 2, this is also 2. Yeah. So this is balanced now. So H2 is breakdown into the H2 and O2. Basically H2 is hydrogen. So this has to be gas. Done. That's why to find the doing the decomposition of the ammonia and made the balance of it. So ammonia is in your formula sheet. If you don't know, the ammonia is NH3 gas. And this can be made by the nitrogen N2, which is gas, plus hydrogen, again gas. Now we have to just balance this. So this is 2, we have to write 2 over there, and 6, yeah, 3. So now this is also balanced. So the demonstration is very easy. You can do the practice of this. If you do the practice of this regularly, you can come to know that how can we make the reactions in like in a minute, in a few seconds. Now we have a single replacement. So single replacement means that things can be replaced between the elements. So an element reacts with a compound. An element, which is A, reacts with a compound, which is BC, to produce a new compound, and an element was a part of the original compound. So what they do, that we have an element called A and we have a BC, which is a compound. What they do, that B goes out as an element and A goes in as a compound with AC. So how can we do this actually? So we have a cobalt, the reaction of cobalt with a silver nitrate solution. So silver nitrate is a compound and cobalt is your element. So CO, which is solid, reacts with AgNO3. You have to know that this has to be made like this, and this should be aqueous because this is a solution. So this is Ag plus, and nitrate is your polyatomic thing, which is NO3. So when we do the CO goes with NO3, so CO has 2 positive. You have to know this. So this goes like this, NO3 2, but this is again aqueous. You can check from your solubility table, and that silver goes out as the element which is solid. Now you have to balance this. So we have a 2 cobalts over there and 2, and this has to be 2, this has to be 2. So this just interchange things. The cobalt goes over there with the compound and Ag goes out from the compound. They go into single replacement. Like in next one, you have a reaction of chlorine gas with the aqueous nickel second bromide. Second means we have to use a 2 positive. So bromide is Br minus. So we have Cl2, which is gas, plus NiBr2, which is your aqueous thing. They already mentioned over there. So when they do, so Ni goes with now Cl2. Why Cl2? Because this has the one negative, this Br2 also has one negative, and nickel has 2 positive. If we do with like Cl2 with Br2, will that nothing, because one is the both has a negative signs. We have to use the things which have one has negative and another has positive. So we have to use nickel with chlorine, and bromide goes out. So we have Ni, so NiCl2 there goes with aqueous thing again, plus Br2 liquid, and this is already balanced. Yeah. So that's how this sometimes works. You have to know the science. So don't do everything as the same. Check the anion or cations thing. So that's for single replacement. Next we have a double replacement. When we do the double replacement, so it's the same as the single one. We do single one, now we have to do double one. So two compounds reacted to produce two new compounds. Like AB with CD will make now AD, A with D, and B with C, which is CB. So we have to write the reaction of aqueous lead second nitrate and aqueous sodium iodide. So what's that thing? So we have a lead second nitrate, which is NO3, nitrate is NO3, PB is lead is PB, which has two positive, yeah. So PB NO3 2, done, and this is the aqueous. Plus we have aqueous sodium iodide. So sodium iodide both has this has a positive, this has a negative one and positive one. So it was NaI aqueous, which will give like now PB is 2 positive, this has a 1 negative, this has a 1 positive, this has a 1 negative. So NO3 goes with Na, which will make NaNO3 aqueous. You can check the solubility table. And PB goes with I, which is PbI2, which is solid. Now you have to balance this thing. So this is 2 and this is 2. This is balanced. So this has pretty much long because we have 4 compounds in this. We have to do again with 4 compounds. So these how the double replacement works. Again, we have a reaction of sodium sulfuric acid with the sodium hydroxide. So now we have a sulfuric acid, which is H2SO4 aqueous, which is your acid base cable for this formula. Sodium hydroxide is NaOH. This is aqueous. You can check the solubility table for this. Now when we make this, we have a plus thing in this, we have a plus 1 and minus 1 in this, we have a plus 1 and minus 1 in this. So you can make by the H2 with OH, which will make you OH2 HOH, which is H2O liquid, and we have N2SO4, which is aqueous. You can balance this. So this is 2 over there and 2 over there. So that's how the double replacement works. And very important, all the reactions. This is very important, double replacement is very important. Last, we have a hydrocarbon combustion. What is hydrocarbon? Hydrocarbon is when any molecular compound is made with the hydrogen and the carbon, which is called a hydrocarbon. We do the combustion in this. So the compound containing the hydrogen and the carbon reacts with oxygen to produce the carbon dioxide gas and the water vapor. Always when we're doing the combustion thing, we always get the two things, which is carbon dioxide and water. Both should be gas. So combustion of pentane, they're giving us the formula C5H12. So C5H12, this is liquid they mentioned, plus O2 because this is a combustion, and we will get CO2 always plus H2O gas because this is a water vapor. Now this thing has to be like difficult to balance. We have a 5 carbon over there, we have 1 carbon over there, so we have to write 5 over there. But we get 10O, which we have like 10O, and we have 1 again, the 11. So we have H2 over there, 12, so we have to write over 6. 6 and 10 we have 16, so we have to write 8. So 8 2 is 16. So that's how this all works. The balance is very difficult, but you have to know that you'll check again and again. Next, we have a combustion of methanol, which is CS3OH. Again, liquid, reactive with oxygen. We will get CO2 gas plus H2O gas. To balance this, we have carbon, we have 2. Okay, we have to write 2 over there. And 4 now. Yeah, so this goes to 2 and this goes to 3. So that's how this balance, and the balancing again, check the balancing. Oh, this is difficult somewhere. So that's the last one, and we completed the types of reactions, and you have to do lots of practice with this. In next topic, we're also doing the same thing. We're also doing the same equations, but with the net ionic. That what is ionic thing? We discuss that in the next one. So that's all for this lesson. Let me see where to vibe learn but not harder. Please like and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till let's get it with EduVibe.